I do some right old lady. What? I didn't even notice. It was at like a party.
That's creepy.
Yeah. She's really old and I never realized it.
Okay.
Zoe,
Zoe's here.
Yeah, I was like,
Did you come across?
she should have been writing for sure.
And at the break, I'll collect your work. Got it. Deep breath in.
I'm on there.
Yeah, I'm on there twice. So just so you know, what happens is I log in through my iPad and through my computer. So I'm logged in twice because to be able to share my screen up here, it has to come through the computer to go to my here. So
Wow, so talented.
I know I'm really proud of myself for figuring this out because that is not my strong point.
That's really proud of you.
I appreciate that, Evelyn.
Yeah, in science class the first week it was hard because she couldn't get the whiteboard to it. So she was having to show the page and we're like, you can't see that. It's just like white.
Yes, that is yours. You can put your name on it. We're going to talk about it in a minute. Okay. Now, few options. I don't want side by side though. There we go. Okay.
It is.
Unfortunately, the amount of stuff that we can't cover in class ends up having to become homework, which ends up spilling into, I did not give work over the break, but it may be that whatever we're behind on will end up having to be called up on over a break, and I don't want to have to do that. So anyway, all right, let's get ready and get started. Hopefully you've had some time to catch up and chit chat and stuff like that. So use break time to do that again. What I want to do is go ahead and start back in this unit because this is going to be lessons 22 through 26 are going to be what we're working with this unit. And so I want to make sure that we go through it all, make sure we have time to ask questions. You got some worksheets that are going to be counted as a grade, okay? Answers will not be sent for these. These are assessing your performance on these particular skills that we've been working on for a while, okay? So I want to make sure that we're good with everything as we continue to move forward. So lesson 22 is where we're going to start, and this is we're going to be reviewing basically when we were working with rationalizing our denominator, okay? So rationalizing the denominator is a skill that continues out through this whole entire section. So whether we're multiplying or dividing radicals, I end up having to check to see if my denominator has to be rationalized, okay? So we've talked about one of the most important things with rationalizing the denominator. Number one is looking at the index, because the index tells me how many times I need to multiply my original problem by a fraction with the same numerator, same denominator to be able to clear that radical in the denominator, okay? So if I have an index of 2, how many times do I have to multiply to get a radical out of the denominator?
One time.
I have my original problem and I've got to multiply it by another fraction. So we've got 2 things multiplied together, but I've only had to multiply it 1 time. If my index is 3, I have my original problem and then I have to multiply it 2 more times. So I end up with 3 denominators being multiplied together. If my radical is 4, same thing. I have my original, I have to multiply it 3 more times to have 4 denominators to multiply by each other to eliminate the radical. Now, once I've done that and I've eliminated my radical, what is my final step always going to be when I'm dealing with radicals?
Reduce.
Simplify, reduce, whatever you want to call it. Absolutely. And what does that mean? When I'm dealing with a radical, what does it mean to simplify or reduce?
Buddies come out.
Okay, dividing. Maybe I'm dividing whole numbers. Hey, did you?
It's a king lunch.
That's okay. So we have to either, we've got to look and see, can I break down buddies? Can I pull my buddies out to simplify a radical? And then if I've done that, do I have a number in my numerator, a number in my denominator that can be divided to simplify? Okay, so that's what we're looking for in simplifying. All right, so that was rationalizing the denominator. Go ahead and turn to lesson 23, flip the page. This is dividing radicals. We learned that the first thing I want to do is divide my coefficients. My coefficients are my whole numbers that are in front of the radicals in the problem. So my first thing I want to do is divide coefficients if they can be divided. My second step is to divide my radicals. And remember, dividing radicals, I am just dividing the exact radicals as they are. I'm stacking them as in fraction form. And then I go ahead and cancel by reducing, okay? So I say, hey, they're both divisible by this number, mark it out, divide, and simplify. By doing that, that means I'm going to be dealing with smaller numbers when I finally have to rationalize and simplify, okay? So if I divide those first, I've got my smaller numbers. So our first step, again, was to divide coefficients. The second step was to divide the radicands. Third step was to rationalize the denominator, and then we simplified as much as we could, whether it was breaking down the resulting radical in the numerator or canceling numerator and denominator coefficients. Any questions on that? All right, go ahead and move on to lesson 24. Multiplying. Okay, so we've talked about how anytime I see something outside of parentheses, anytime I can see that I've got something outside parentheses, I know I'm going to have to distribute it. And to distribute means that I have to apply it to everything inside parentheses. Okay, so in this situation, I'm multiplying. If I see something right in front of parentheses and it has no symbol, division, addition, multiplication, whatever, I understand that that is multiplication. Okay, so that means I have to multiply it by each term inside. And then I go through the same process. I combine like terms if I have like terms. Like terms means whole numbers with whole numbers, radicals with radicals, that kind of stuff. Also, I'm looking to see about simplifying. One of the biggest things, just like I'd be willing to bet that with fractions, one of your biggest hangups and one of the biggest things that it's been the hardest or the most annoying, I guess, with fractions is reducing and simplifying. I remember I used to get super annoyed. If my answer is an equivalent fraction, why does it matter if I simplify? Well, it just does, okay? Because you've got to have your answer in simplest form.
That's a good.
Same thing with radicals. Why does it have to be simplified if they're equivalent? Well, it just does, you know? Sorry. So anyway, y'all have seen that on tests and assignments and things like that, I'm not going to count your problem wrong if you forgot to reduce, but I do count a point off. Or sometimes I've adjusted it to a half point or a quarter point, just depending on the situation. So just know that I will not count it wrong for not reducing, but I will count off points. So if you don't want to lose points for it, make sure you do that step. All righty. So that was lesson 24. 25, we moved along where we were dividing, and we had this similar situation where we've got parentheses with multiple terms, but now we do have a symbol outside parentheses, and it tells me I've got to divide. Same thing with multiplying when I have to distribute, meaning I have to use each term inside parentheses with the term outside. Same thing with dividing, okay? So when I'm dividing, I have to distribute that term on the outside. So I have this term divided by square root of 2 and this term divided by square root of 2 separated by the plus sign. So you just set up your problem the same way, okay? Any questions about lessons 22 through 25? As you did your homework, as you did your corrections, did you see, number one, if you were making mistakes, what mistakes you were making? Was it a consistent thing? Did you forget that you were, instead of multiplying, you were adding when you pulled your buddies out? Did you look and see, oh, well, I messed up, I forgot to reduce? Or did you see that it was, maybe you didn't make any mistakes at all, and that's fantastic, okay? So the main thing, though, is just follow the steps. That's why I'm having you write those lesson directions at the beginning, so that way you've got them right in front of you to look back to. You don't have to flip back in your book and figure out where they are and all that good stuff. So any questions that we need to go over on any of these lessons, the homework for these lessons? All right, then we're going to move on to lesson 26, which is going to start on page 57. All right, and this is solving algebraic equations with radicals, okay? So it says, okay, you have learned to isolate the variable when solving an algebraic expression. What does it mean to isolate the variable?
To get it by itself.
To get it by itself. You may have to use properties of equality to move things. You may have to move things around. You are trying to get the variable by itself. So that's the biggest thing. When you're trying to isolate it, you want it by itself, okay? So it says, but what happens if that variable is under a radical? You cannot just pull out the variable. Look at what happens when you remove part of a radicand, okay? So if we look at the square root of 8, it says the square root of 8 equals the square root of 4 plus 4. So far, this is a true statement, but you cannot split a radicand. So you have to look at this as the square root of 4 plus the square root of 4. And so that does not mean that the square root of 8 is equal to, so basically, I can't just take these apart and say, okay, the square root of 8 is equal to the square root of 4 plus 4. Okay, so 4 plus 4 does equal 8, so this is true. But I cannot break this into the square root of 4 plus the square root of 4. Because when I look at that, the square root of 4 plus the square root of 4 is going to be 2 plus 2. 2 plus 2 is not the same as the square root of 8. Okay, so I can't just break down, when I have a plus or minus sign in between terms underneath the radical, I cannot break it into two separate radicals using that symbol in between. So it says, if you have a square root as part of an algebraic equation, follow these steps. So what do you think is going to go in your lesson notes for your homework tonight? Here they are, right here for you. Step 1, isolate the entire radical, then just the variable. This is true no matter where the variable appears in the equation. So you've got to isolate the entire radical first. Step 2, square both sides of the equation. What does that mean?
You like put it in the square root?
Not square root. If I'm squaring something,
Multiply it by itself.
multiply by itself. Exactly. When I square a number, I'm multiplying it by itself. Okay, so 6 squared is 36 because 6 times 6 is 36. So I'm squaring. All right, but notice, why do you think it says both sides?
So it's even?
So it's even, so it's balanced. Whatever I do to one side, I have to do to the other. So square both sides of the equation. The next step says solve for the variable following the properties of equality. So now we go back to just regular following our steps of equality. And then step 4, check for extraneous solutions. What does that mean?
You have to see if it's equal.
You have to plug in your answer to see if it makes a true statement. Okay, so you do need to plug in your answer to check if it's a true statement. Yes.
How do you plug in it? How do you like check it?
Okay, we'll go through that. We will work through that. So basically you say if x equals 2, then when I go into my problem, I plug in 2 for x and try to solve it and see if it's true. See if that answer works. Okay, so we'll work through that.
And if it's not, you just say it's not.
Exactly.
Okay.
Okay, so let's take a look at this example. Look at the example they've given us. The square root of 5x plus 4 minus 2 equals 5. What does step 1 tell us to do?
You have to isolate the radical.
Isolate the radicals. So what is with the radical that needs to move from the left to the right?
-2.
-2. How do I move -2?
You do +2.
I'm going to add it. So I add 2 to both sides.
Which makes 7.
So add 2, add 2. So then we get to the next step where we see I have got the square root of 5x plus 4 equals 7. Okay? So you may want to make sure you're following along, because if I ask you a step and you're not prepared, then I'm going to know you're not paying attention. All right? So the first step we had to do was add 2 to each side to be able to isolate the radical. So that was step 1. What is step 2?
Square both sides.
Square both sides. So notice when we got to the square root of 5x plus 4 equals 7, this is where we got to when we isolated the radical. Now next step, bless you, is to square both sides. So that means we put the radical in parentheses and we've written an exponent of 2. So I am squaring this side, but I have to also square this side. So now I have 7 squared as well. So I put my radical in parentheses with an exponent of 2. I have my 7 that is on the right-hand side with an exponent of 2. What I do to one, I must do to the other. Okay? So now, remember how we talked about if I have the square root of 7 times the square root of 7? Oh, that's about 7. What does that equal? 7. So if I square something, if I multiply it by itself, whatever was under the radical comes out as a whole number. So if I square 5x plus, if I have the square root of 5x plus 4 squared, so I have the square root of 5x plus 4 times the square root of 5x plus 4, what is going to come out? 5x plus 4. So when I square a radical, by multiplying it by itself, it allows the radical sign to go away. And I'm left with just the radical, what was the radicand?
5x plus 4.
So now I have 5x plus 4. Remember, we had 7 squared, so that's 49. So now I've got it in a format where I can go ahead and use my properties of equality to solve. So if I've got 5x plus 4 equals 49, what's my first step?
You're going to
Subtract 4 from both sides. So I end up with 5x is equal to 45. What's my next step? Divide by 5. Divide by 5. So x is equal to 9. Okay. Now, this comes in with our extraneous solutions. Okay, this is the part where it says to check it. So notice here, we just said that x equals 9. Okay, in my original equation, I hate it when they don't put the original equation to start with. Let's look back at our original equation, which was 5x plus 4 minus 2 equals 5. This is the point where I'm going to sub in 9 for x. Okay, we just solved and said that x equals 9 in this problem. So now to check for an extraneous solution, I want to plug in my value of 9. So that's what we've done down here. They said, okay, then 5x, or we found that x equals 9. So 5 times 9 plus 4 minus 2 equals 5. So I'm plugging in that 9 there. So I have the square root of 5 times 9 plus 4. The square root of 9 times 5 is 45 plus 4 minus 2 equals 5. I'm going to clean this up a little bit. So now I have the square root of 49 minus 2 equals 5. What is the square root of 49?
7.
7. So 7 minus 2 equals 5. 5 equals 5.
Wait, what happened to the 4?
Okay, so let's take a look at it. I started here and said 5 times 9 is 45 plus 4.
Okay.
45 plus 4 is 49. Okay? If I end up with an equal sign and this side equals this side, I know I have a good solution. If I end up with something that does not equal the other, then it is extraneous. It means that even though it worked in the beginning steps, it is not a true solution for the problem. Okay?
Why is it 5 and not 9? Because it's extraneous.
Because, no.
It's not extraneous, that's what I meant. Okay, he tried to have a big brain.
So we're trying it because x, this is where x was. Do you understand that in the problem, this was where x was? So when I said x equals 9, I'm plugging in 9 where x was. So when I use x as 9, then it gives me a true statement. Okay, so I'm not solving down here. I should not come up with 9 again. I might, but I shouldn't. It's probably going to be different numbers. It's going to be different numbers. Okay, so where the 9 goes is where x was. So let's work through the first one in classwork. Okay. 6x plus 7 minus 2 equals 5. You don't know who I'm going to call on to ask for the first step. Sadie wants it to be her. What is my first step, Sadie?
Plus 2.
I'm going to add 2 to each side because I need 4. Why did you add 2?
Because you have to isolate the radical.
Isolate the radical. So now I have the square root of 6x plus 7 equals what? 7. All right. What is step 2? Everyone? Okay, I need to square both sides. Let me make my tip a little smaller. Okay, so I'm going to put parentheses. Actually, I'll change my color. I'm going to put parentheses around my radical and put my little exponent of 2. Put parentheses around 7. Square root of that. Step 2 is to square both sides. So step 1, we got it to where we moved the -2. So my radical is by itself. So now I need to square it. I'm squaring both sides. When I square the square root of 6x plus 7, what does it become?
6x plus 7.
6x plus 7. So now I have 6x plus 7 equals
49.
49 because 7 times 7 is 49. Questions at this point? Zoe?
Why did the radical go away?
Okay, because our second step says that we need to square both sides of the equation. So that was why I put the parentheses around it. So in our example, they put parentheses around it to square it because step 2 tells me to square both sides. So I had to put parentheses around it and put an exponent of 2. And then same thing here. So remember when we said that if I had the square root of 7 times the square root of 7, that would just equal 7? When I square it, whatever is under the radical comes out as by itself. So underneath here, go ahead and write 6x plus 7. Yes, because the index is 2. So I have to square it to get it out from under the radical. All right. Yes, ma'am.
6x plus 7 doesn't change.
Okay, because remember, think about this real quick. Everybody listening? Everybody listening? Remember how we said the square root of 7 squared would be the square root of 7 times the square root of 7, right?
Yes.
And because my index is 2, I need to multiply it by itself 2 times for my radical to go away. So when I square it, when I multiply it by 2, my radical sign just goes away. And I have what was underneath the radical. Same thing up here. When I've got 6x plus 7 squared, this is what is under the radical. So when I multiply it by itself, then that means my radical goes away and this stays. Does that help?
Yeah.
All righty.
And then don't we like subtract 7?
So now we're going to solve for what?
We're going to solve for x.
We're starting to solve for x. So what is the first thing that I'm going to do, Chad?
Minus 7.
What is the first thing I'm going to do, Chad?
Okay, add 7 or subtract the 7.
Which one?
49.
Okay, subtract 7 from 49. It is being added, so to move it, I have to subtract it. So now I have 6x is equal to, what is 49 minus 7?
42.
42. What is my next step going to be?
Divide by 6.
Divide by 6, divide by 6. So x is equal to 7. Okay, we have solved for x. What is our next step? Okay, so what I'm going to do is I'm going to come over to the side. And I'm going to check for my extraneous solution. So I'm going to start with the square root of 6x plus 7 minus 2 equals 5. So remember, this is where I'm plugging in what I just solved for x.
Oh.
So what I like to do is notice I went ahead and rewrote this problem. And I put parentheses for x. Is everybody with me?
Yes.
Parentheses are where I had x. What number is going to go inside parentheses?
7.
7, because that's what I just solved for. Okay? So now I've got this square root. What is 6 times 7? 42 plus 7 minus 2 equals 5. What is 42 plus 7? 49 minus 2 equals 5. What is the square root of 49?
7.
7 minus 2 equals 5. What is 7 minus 2?
5.
So 5 equals 5. I hope you went ahead and wrote all of this down in your book. So did you do the work along with us? Yes.
Does it work if I do it that way too?
Yeah, absolutely. Absolutely. So one of the things that Kinsley did was she went ahead and she went ahead and said, okay, what if I wanted to move my 2 and have this root of 49 is equal to 7? So what she did is she went ahead and added this 2 to isolate my radical. So she said, okay, so I've got 49 equals 7, so 7 equals 7. As long as you've got a true statement when you get to the end and you've got something equals something, then you know that you have a correct solution.
Wait.
Well, no, I mean, but see, this is so you wouldn't hand this in for homework because this is not homework. So if you want to write it on your page, that's great. But then you'll have to do another sheet for homework. So right now you're doing these examples in the book, and then your homework is on the paper.
Why is it 7 equals 7?
She doesn't know that too.
Okay,
She
what is the
keeps-
square root of 49?
She keeps the 2.
All righty, let's look at the next one. What is step 1?
To isolate.
What needs to move?
8.
8. How is it going to move?
Subtraction.
Subtract 8 from each side. So I have the square root of 3x minus 2 is equal to
-5.
-5, because 3 minus 8 is -5. All right, what's my next step? I need to square it. So I'm going to put my parentheses around the sides and exponent of 2, parentheses, exponent of 2. So what is the square root of 3x minus 2 times the square root of 3x minus 2? 3x minus 2. What is -5 squared, or -5 times -5?
Just 25.
Is it positive or negative?
Positive.
Positive, because it's a negative times a
Yeah.
negative. So I have positive 25. Be very careful when you're dealing with your signs. Think about those rules. So I have 3x minus 2 is equal to 25. What am I going to do now? Add 2. Add 2. So 3x is equal to 27. Next step. Divide by 3, divide by 3, and x is equal to 9. Okay, so we have solved for x. What is my next step? Check for extraneous solutions. So I'm starting with the square root.
Wait. My calculator is saying it's -23. But that's your calculator.
Okay, so listen,
I got
when
my calculator.
Chad, when you did -5 times squared, what is that? What is -5 times -5? No, a negative times a negative is a positive. A negative times a negative is a positive. Okay, so that's why you ended up with, guys, I'm done. Done. I tried to nicely handle it right before we got a break. I understand we've been on break, but come on, guys, you're being rude. And that's where I draw the line. I've asked, I've tried nicely, but I'm done. Okay? There are people trying to learn. If you don't want to learn, that's fine. So be it. But I'm not going to put up with it. Okay? So here we have our original equation. We're going to plug in for x. So again, I have my 3. I'm going to put parentheses for x and write everything else exactly the same. What did we say we solved for x? What was it? 9. So I put that inside my parentheses. All right. So now I need to go ahead and start solving. So I've got the square root of, what is 3 times 9?
27.
27. So it's still under my radical. I have 27 minus 2 plus 8 equals 3. What is 27 minus 2? 25. So now I've got the square root of 25 plus 8 equals 3. One of two things. You could go ahead and find the square root, then add 8 and see if it equals 3. Or you could start by moving the 8. It's up to you. What is the square root of 25? 5 plus 8 equals 3. What is 5 plus 8? Close. 13. Now, I've ended up with 13 equals 3. Is that a true statement? No. So what does that mean? This is what kind of solution? It is extraneous because 13 does not equal 3. Okay? So remember in the first one, we found where we ended up having the number on the left was equal to the number on the right. We had 5 equals 5, or if you solved it the other way, you had 7 equals 7. The number on the left equaled what was on the right. But now on this one, we came up with an answer where the number on the left does not equal the number on the right. So that is considered an extraneous solution. So that means that when I put in 9, it does not give me a true answer. Yes.
I got 25 equals 25.
Okay, so let's see what you did. So what is the square root of 25?
5. Oh, I have to do that.
Yeah, you've got to take the square root. I can't just say the square root of 25 is 25. I've got to have the square root. Now, if we had done it a different way, if we had done something differently right here, we could have subtracted 8 from each side and had the square root of 25 is equal to -5. So then the square root of 25, hold on a second. The square root of 25 is equal to -5. 5 equals -5. Those don't equal either. So either way that I do this, whether I start here and go all the way down like this, or if I move that 8 over to the right-hand side by subtracting it and end up with 25 equals, I'm sorry, the square root of 25 equals -5, because 3 minus 8 would be -5. Square root of 25 is 5. -5 is -5, so those are not equal either. So it doesn't matter which way I go, it's still going to be a non-solution. It's still going to be extraneous. Okay? Let's go ahead and take a look at activities 2. I want you to work activities 2 right now. Go ahead and do these 2 problems.
Do you do it on like paper or?
It is totally up to you where you do it. It's just not, it doesn't need to be on the homework paper that you turn in. So you're welcome to work it in your book or a separate piece of paper, but it will not be on what you turn in.
Yeah, it's a trouble.
No, I mean like I can't write.
That's also. I can't fit that.
If you have questions, let me know and I'll be happy to help you. Okay, so what's your next step? What's step 2? Okay. Now, the whole point of squaring is that it makes the radical go away. Now, by squaring, remember that makes the radical go away. Okay. Isolated, some square brackets out, so now that's not how did you get X, Y, Z? No. But how did you get 2X, Y, Z? What did you do? Okay, so you added 13, so you end up with 94, and then you add that 2. So now you have X is 47, so again, that's where you can plug in the value of X. That's it. Okay, so let's take a look at this. Okay, so step one was to isolate the variable. Okay, go ahead and take a break. Isolate the variable. Step two. Okay, so did you do that? Okay, so right here. Go ahead and insert. Alright, see that I'm doing radical. So if you go like radical, the radical is always for root symbol. It means something on that. Put the parentheses on the outside of the radical. So now, I will make some notes here. This side, you have to square this side. Take the parentheses around that. So now, the square root of 2x minus 13 times the sum of 2x minus 13. Squaring it like this. And here, and square it here. So now, I have to say, so now, if I squared this, what am I going to have left? 2. Good, fine. Now, what's on the right hand side? Stop there and come back and then solve this. Okay? Question? Okay, Zoe, let's go ahead and get your homework assignments. So lesson 22.
Oh, I didn't say that.
Okay, I have stuff on.
Do you want to do from the back or?
So let's start with lesson 22.
I'm gonna do corrections. Do you want to do from the back or?
Okay, so going forward, what I want you to do is do corrections per thing. So like for lesson 22, you would have all your work and then corrections would be with it. Then your next lesson, do your work, corrections would be with it, okay? Also, at the top, I need you to mark how many you had to correct per lesson. If it's none, then you would just write -0, okay? So let's go ahead and take a look at these. This is lesson 22. So you didn't check it?
I just checked it. Right now I have to like grade it.
Oh, yeah, that's the part where I said with a bright colored pen or a marker or something to mark the ones you missed so they'd stand out.
First time I missed lesson 23.
Okay,
But
okay, is it, or is it this one?
yeah.
Okay, so at the top of this one, go ahead and get your pencil and put -1 up here, so I'll know to look for a correction. And circle it. Go ahead and circle it. Here we go, so I'll know that I'm gonna look for a correction for this one. If you didn't have any on this one, put -0. Okay, now, second with this one, lesson 24. Okay, so -2 and circle it. Okay. Oh, 24. Okay. So now I'll know. And then next time for the next homework assignment, just do your corrections immediately following the work. So like you could have done corrections on the back of this page. Just write corrections at the top. So that's just fine. Okay.
That's okay.
Yeah. Oh, absolutely.
Oh my gosh, that's just.
I am.
Hey, you need to chill out.
Oh, there's a chair there.
Next week that we're back, like same class.
Chill out.
It's crazy. The bathroom test. Name. Spell it correctly, and they know that word and like what year they came in. So like, it's taking our water. I also let that as me. I know, and they're not, they don't follow it. No, no. I like this wrong.
Get back to work.
I didn't.
Solving the problem. Checking for extraneous solution.
Okay. Well, remember, we're doing, actually, we don't need that extra. So, when I square a radical, when I multiply it by itself, it means that I'm just gonna drop the radical. So everything stays the same under the radical sign. So equals is 9 squared. Good. So now we solve for x. You work. So this is what I said right now, I'm -3 with it, so I need to add it to both sides to get it to move over. Okay, so underneath it is like +3 and +3. Okay, so now I've got the square root of 2x minus 13, and I have moved that too because negative and plus root is 0, right? So now on this left hand side, I have stuff like the square root of 2x minus 13, so like that. Plus. Now, on this side, that's it, and we're adding 3, so now we have 6. Okay, and that's also going to be okay, so now Go ahead and put parentheses around article. This is x under 2. Put on 9. X under 2. So now when I square this, so I have the square root of x minus 13 times the square root of 2x minus 13. That means my radical sign is just going to go away. And all I'm going to be left with is 2x minus 13. When I'm solving for x, I'm trying to figure out how to do a minus 7. Okay? So, guys, okay, so I'll use reverse tendency. Okay, think about when I'm gonna solve something or when I do a problem, when I'm trying to solve for a variable, I'm gonna do it reverse. So that means the first thing I want to do is addition and subtraction. I want to undo addition and subtraction. So whatever here you've got subtraction, how do you undo subtraction? What is the opposite of subtraction? Okay, so then undo this from this side to this side. So now if I have a negative 13 plus 13, that's a 0, right? So what do you have left over here? 2x, equals. Now we got 81 plus 13. Okay, so now what am I going to need to do? What operation is this right here? I have another next to variable. What operation? When I have a number next to variable and there's no sign in between them, they're side by side, I understand that that's multiplication. How do I undo multiplication? Good. So draw a line underneath 2x and the 2 below it. We're divided by 2. But our whole goal is to get x by itself. If I divide this side by 2, what I have the other side. Awesome. So, 2x divided by 2.
Same things, but I just figured. We get a pack of 20 for like $2. It was like 2. No, I thought you were saying it's a ring.
Okay, so is this going to be positive or negative? I've got negative 6. Go ahead and put that negative 6 in parentheses. If I'm squaring negative 6, that means I've got negative 6 times negative 6. Good. So that's good. Okay. Okay. So that means you're putting in a 5 right here where you got x, right?
My mom made Christmas tree yesterday in my room.
Yes,
I've been listening to Christmas music for a month now. Yes, I can. I'm trying to convince my parents to let me put up the Christmas tree on Halloween, but they won't let me. But it might just I never listen to it all year.
All right, let's go ahead and go through these.
Get this hooked back up. All righty. Let's look through. If you're not quite finished, keep going.
Okay.
But let's look through what you've done. Remember, the whole purpose is in going through those steps is to tell you, do this first, do this second, do this third, okay? So it's right there in front of you on what you're supposed to do. So if you get stuck, look at your steps. What is step one?
To isolate.
Isolate. So what needs to move?
3.
How do I move it?
Adding it. You add the 3.
I add 3 to both sides. So I end up with the square root of 2x minus 13 equals
9.
9. What is my next step?
Squared.
I need to square both sides. Remember, squaring both sides, I'm going to put parentheses around each side and put an exponent of 2. This is an important step, especially when this number here is negative. Because if you do not do a negative squared, a negative times a negative is a positive. If you just put in, and so that's one of the things I want to mention to you really quick. This series does not do a very good job of telling us this, but so if I have negative 9 squared, and then I have negative, well, not that, go back, parentheses with a negative 9 squared, these are two different answers. The parentheses make them different. This is read as the opposite of 9 squared. What is 9 squared?
81.
What is the opposite of 81? Negative 81. So if there are no parentheses, then I am going to have a negative answer because this is read as the opposite of 9 squared. So it would be negative 81. If my negative is inside parentheses, then that means I'm multiplying a negative times a negative, which is positive. So that is why I like going ahead and putting the parentheses there, because then when I plug in my value, I make sure to get my signs right. Okay, so that's why I like going ahead and putting the parentheses instead of just doing 9 squared. Go ahead and get in the habit of putting parentheses around each side and then put your exponent of 2. So we talked about the square root, the square root of 2x minus 13 times the square root of 2x minus 13 equals?
2x minus 13 equals
2x minus 13. So all we had to do was drop the radical. Equals, and 9 times 9 is 81. Now solving for x. Remember when we undo our problems, we're doing reverse PEMDAS. And we're having to use opposite operations. So to undo subtraction, I use addition, and I'm subtracting 13. So what do I add? Add 13 to each side. So 2x is equal to 94. Now I have 2x equals 94. When I have a number in front of a variable, that is multiplication. So how do I undo multiplication? Divide by 2, and x is equal to? 47. So now I've got to plug in and look to see if my solution is a true solution or if it is extraneous. And the way I will do that, let's see. So I've got the square root of 2x minus 13 minus 3 equals 6. The square root of 2, I'm going to go ahead and do my parentheses. Now I'm plugging in 47. What is 2 times 47?
94.
94. You can easily figure that because you look back at your problem. You just said that 94 divided by 2 is 47. So up here, 47 times 2 is 94. It's right there for you. 94 minus 13 minus 3 equals 6. Under my radical, I have 94 minus 13 equals
81.
81 minus 3 equals 6. What is the square root of 81?
9.
9 minus 3 equals 6, and 9 minus 3 is
6.
6 equals 6, so it is a true solution. Okay,
Equals 9 because
got this.
you went ahead and did the square root of 81 equals 9 because you added 3 to each side, and so 9 equals 9. That's fine. Depending on how you do which step you do, if you go ahead and simplify here, you're going to end up with 9 equals 9. Again, if it's a true statement, it's going to be a true statement no matter which steps you go through. If it's extraneous, it's going to be extraneous. Okay.
So as long as it has the same.
As long as you end up with something equals itself, absolutely. Okay, next one. I have the square root of 7x plus 1 plus 13 equals 7. What is my first step? Isolate. What do I need to do to isolate?
Subtract 13.
Subtract 13 from each side. Look and see, did you subtract 13 from each side? So I'm left with 7x plus 1 is equal to, what is 7 minus 13?
Negative 6.
Negative 6, good. Next step.
Square.
Square both of them. So put my parentheses around them. Exponent of 2. This is where it comes in, where it's very important that we put that negative 6 in parentheses, because now I've got a negative times a negative is a positive. So the square root of 7x plus 1 times the square root of 7x plus 1 equals 7x plus 1. My radical goes away, equals negative 6 times negative 6,
36.
positive 36. What do I need to move first?
The 1.
Subtract 1, subtract 1. So 7x equals
35.
35. Next step,
Divide.
divide by 7, divide by 7. So x equals
5.
5. So I found that x equals 5. How do I check it?
Plug it back in.
Okay, so I've started with the square root of 7x minus 1 plus 13 equals 7. So I'm going to plug in. So I have 7. I'm going to put my parentheses, minus 1 plus 13 equals 7. I'm going to plug in that 5 there. Okay, so now I have 7 times 5 is
35.
and I have 35 minus 1. It's supposed to be plus 1. Plus. Oh, that's terrible. Plus. Okay. We said 30. Okay, so we've got the square root of 7 times 5 is 35 plus 1. We still have plus 13 equals 7. What is underneath my radical 35 plus 1?
Oh, it's 36.
36 plus 13 equals 7. What is the square root of 36? 6 plus 13 equals 7. What is 6 plus 13?
19.
19 equals 7. True or false?
Oh,
False. So this is
Yeah.
extraneous. Okay, so let's go ahead and take a look here. If you had gone this step here and you went ahead and subtracted 13 from each side, you'd have the square root of 36 is equal to, let's see, 7 minus 13 is negative 6. So then you would have 6 is equal to negative 6. And again, that is still not true. So it's extraneous either way you go. Okay. All right. So the first one was a true statement. Look back at which section?
The 22.
Look at, see which section is about dividing radicals. Turn to the lesson on dividing radicals.
Oh yeah, it's 23 actually, guys. I'm sorry.
We just went through them at the very beginning of class.
Is it this 23? 23. 23.
What lesson in your textbook? Remember, all of this is going to relate to a lesson we have previously learned in the textbook.
It's 2 lessons.
Dividing radicals goes with what lesson in the book?
23.
Lesson 23. At the top of this worksheet, write, look at lesson 23. In your textbook, go ahead and turn to lesson 23. That is on page 51. Turn to page 51. If you want to go ahead and write page 51 at the top of your paper. Now, what are the steps for dividing radicals? What is step 1?
Divide the coefficient.
Divide the coefficient. 2.
Divide the radicand.
Divide the radicands. 3. Rationalize. 4.
If needed.
Use your textbook to do this page. Don't try to wing it. Look back at your steps. Sadie?
Do we have to, for the packets, do we have to write them on notebook paper?
You do not have to write them on notebook paper. Remember, on these, you can write on here if you have enough room, but I must see every step. I will not accept just answers. Okay, let me say that again to make sure everybody understands. I will not just accept answers. I must see your work. If you cannot write small enough to fit all of your work on here, then you do need a new sheet of paper and you will staple it to this. Okay. So the main thing is that we will be dividing radicals on worksheet 13. Turn the page, worksheet 14.
This is gonna be
Multiplying radicals and dividing radicals.
This is gonna be on lesson 24,
Okay.
page 53.
Very good, Evelyn. So lesson 24, page 53. Write that at the top of your page. Lesson 24 is activities 1 on this page. Now lesson 25 is the division part, activities 2. So my top part, so up here is lesson 24.
Page 55, that's so satisfying. It's 25 on page 55.
So what I've done on mine is I went ahead and drew my brackets and said, hey, the top part goes with lesson 24. The bottom part goes with lesson 25. Look back in your book when you're doing this. Okay?
It's only 2 pages.
It's just these 2 pages.
That's so nice of you.
This is due Thursday. Okay? So this coming Thursday, when you come to class, you will be handing this in.
Yes, ma'am.
So let's go ahead and take a look at what our homework is for today. Go to the end of lesson 26. Listen up, please. Lesson 26.
Okay.
Your homework will be, was that page 58?
Yes.
So we will have page 58, activities 3, and activities 4.
On paper? Is that this due?
Okay, so this is what is due on paper. Now listen up. So we have activities 3 and 4. These are the lessons that you do where all you'll have to do for this assignment is this will go along with lesson 27. So you'll head your paper with 26. Put your steps down for your notes. But notice you only have 4 of those problems. So you'll write your name, lesson 26, write down your lesson notes. So you'll have 4 of these problems. Then notice in number 4, activities 4, you do not have to write down the properties that were used. Just show your work. You do not have to identify the properties. If you want to mark that out on your book, you may.
Yeah, I never did that.
Okay, so just solve the equations.
So this
Solve
is
the
due
equation.
the second.
Okay, this is due Thursday. At the top of it, go ahead and write due Thursday, October, whatever the wrong Thursday is.
October 22nd.
Yes, the 22nd. Okay, so today is the 19th. You've got the 20th, the 21st. This is due in class on the 22nd. Okay, hang on just a minute. I might answer your question. This is due Thursday. You will come in class and hand it to me. The homework for lesson 26 will not be due until the following Monday, 2 weeks from today. Okay.
The lesson,
Okay. I want everybody, mouths closed, looking at me. Okay. Everybody's attention. The work from the workbook is what you do your homework assignments on. You do your piece of paper, you head it, you write your lesson number, you write your lesson notes. That will go for lesson 26. You still need to have that done by Thursday because you need to be able to know what you have trouble with to be able to ask for help in class on Thursday, because on Thursday we're getting a study guide for our test on this section. So if you wait and don't do your homework until we come back, you're already had a test on it because you're going to have a test before this homework is due. Okay? This is due Thursday. Lesson 26 will be in your stack of work like you turned in today. Okay? So your first assignment in your next packet that comes in 2 weeks from today will be lesson 26. You'll head it, do your lesson notes, do your work, check it, make corrections. Okay? Is everybody clear on that? Work paper from the textbook is due in 2 weeks, but it needs to be done by Thursday. You don't wait 2 weeks and do this homework. If you do, you will not understand what you need to understand for the test. Okay? So just because you don't actually hand it in until 2 weeks from now does not mean that you don't do it. You need to do it by Thursday, because remember, you need to have done the work. You need to checked it and made corrections. And then if you still don't know what's going on, you've got to be able to ask me in class on Thursday for help. Okay? So you've got to do the work before the next class. It doesn't give you a pass and, hey, I don't have homework till 2 weeks from now. No, you have to have a test. Okay? Do the work, make the corrections, ask questions on Thursday in class. On Thursday, we'll get our study guide. The following Monday, your test will be emailed to you. It will be due that Thursday. Okay? So we'll go over all that. Don't stress right now about when the test is due. It's going to be due in a week. But the main thing is get this homework done. So between now and Thursday, you need to do your lesson 26 homework and your packet or your worksheets. These are handed in on Thursday. Any questions on what is due? Chad?
But I thought you said this was going to be due on the Monday.
That is what I just said, hon. If it is from your textbook, it is due on the Monday that we come back to co-op. If it is this, it is due Thursday. Okay? But what I'm saying, okay. I think what's confusing, you handed this packet in today, right? I hope y'all didn't do all this work last night. Did you wait and do your homework last night? No, you did it when it was assigned, right? So yeah, it was handed in. So your work will be handed in 2 weeks. It will be done this week. Oh, do your work when it is assigned. Hand it in the day you come to the co-op. Is that better?
Correct.
All righty. So don't wait till the last minute to do your work. If you have questions, if you are stuck on something, Evelyn, can I use you as an example?
Yes.
Okay, so this past week, Evelyn texted me and said, hey, I'm stuck. This is what I keep getting. What is wrong with this? So I said, show me what you got. So she took a picture of her work and texted me and showed me her work. And I said, look at this right here. And then she said, oh, no. Okay, so it's the kind of thing where if you get stuck on something, send me a text. I'll probably ask you to show me your work so I can see where you're making a mistake, so I can try to help you figure it out. Okay, so if you're not checking it, if you're not checking your work, you don't know the mistakes you're making, you don't know to ask for help in class, then you bomb your test. Okay, I will tell you that grading will be much more strict. There were some of you that scooted by the seat of your pants this grading period, because with the confusion with all the homework and stuff, I was much more lenient on the homework grading. And so some grades that were in some serious danger zones got boosted up a little bit, okay? Because understanding the first 9 weeks was a little rocky and all that good stuff. This next 9 weeks, grading will be much more strict, okay? So make sure you're doing your work. I feel like now we've kind of got a plan, we've got a system on, it's going to be based on you doing your work though. If you're not doing your homework and you're not understanding your homework, then you're not going to do well on a test, okay? But the only way I know you're not having trouble is if you let me know. And I don't want to go, oh my gosh, they made an F on their test. That means they don't understand any of what we just did. I can't go back and reteach it to you. You can go back and watch the videos. That's what they're there for, okay? Feel free to go back and watch videos, and that's what I may refer to parents. If they're saying, hey, they're having trouble, go watch the video, okay? But if you're having trouble, don't suffer. Don't just sit there and go, I don't get it, and I'm not going to get it, and I'm not going to do it. Tell me. Let me know so I can help you, okay? Last week and the week before, I spent, I don't know how many hours on Zooms with individuals saying, I'm having trouble with something, and I'm here to help. Let me know. Let's set up a Zoom. Let's work through it. And then I think a lot of times after we've done those one-on-one Zooms, everybody goes, oh, now I get it. Okay. So if you need some extra help, let me know. That's what I'm here for. All right. Don't just suffer in silence and go, I don't know what to do and I can't get it and I'm going to do bad. Okay. So please know that I'm here to help. Please know that I'm happy to help. Thank you, Evelyn, for reminding me of that. Let's number our pages in the textbook. So the packet, it doesn't really matter, but the textbook, because you're doing it on notebook paper, obviously, let me change my color so it'll stand out a little bit. So activities 3, we'll have 1, 2, 3, 4, going side to side. And then for the next one, so did you go side to side on the bottom?
Yes, ma'am.
So 1, 2, 3, 4. Okay, so lesson 26, just straight across the top, 1, 2, 3, 4. For activities 4, 1, 2, 3, 4. So go side to side, then go down a row. Okay. So questions about what is due, questions about assignments. We have got, it is 11:48. So we will be starting a new section on Thursday. So this is the time, use this time wisely to work on this stuff so you can get my help right now. We are going to be quietly working, okay, because people are going to want to work. So quietly working, it's 11:48. We get out of here at 12:05. So we've got a good, what is that, 17 minutes, 15 minutes to get some work done, okay? So use this time wisely. Let me know if I can help you. Let me know if I can help. You can either be working on tonight's homework with lesson 26 if you need help with that. If you want to work on the packet, you can be working on that. Whatever you want to work on, just be working. So you can ask for help if you need it. Remember, look back at the lessons. Look back at the page when you wrote. First do this, next do this. Use that to guide you, to help you. Please do circle your answers on your worksheet. Box them, circle them, do something to make them stand out.
Miss Fountain. So would these just cancel out and go away?
Okay, so what is step one? So you divided
Yeah.
79, 72 and 9, good. And now you're going to do the same thing here. You're dividing what by 8? Okay, so 8 divided by 8 is 1, and square root of
Yeah.
1 is?
Okay.
So what's in your denominator? Nothing, right? It went away.
Yeah.
So there's your answer.
Okay.
So then you would just look at that and make sure, hey, is my radical in simplest form? Yep. And so that's it. I guess we don't need the overhead anymore, so I'll go ahead and turn that off. And then
It should hurt your head. It doesn't affect me. It should, but it doesn't. He said to me. Yeah, I was gonna say it should. He's worn sunglasses. Doesn't even affect you. Because he has shit. Now you're giving me more. Oh. No, I'm just saying.